let's do some more non-homogeneous equations. So let's take the same problem, but we'll change the right-hand side, because I think you know how to solve the essentially the homogeneous version. So same problem as we did in the last video, the second derivative of y minus 3 times the first derivative of y minus 4 times the function. And now in the last example, we had the non-homogeneous part was 3e to the 2x, but we're tired of dealing with exponent functions, so let's make it a trigonometric function. So let's say it equals 2 sine of x. So the first step you do is what we've been doing is you take you essentially solve the homogeneous equation. So this left-hand side is equal to 0. You do that by getting the characteristic equation, r squared minus 3r minus 4 is equal to 0. You get the solutions, r is equal to 4, r is equal to minus 1. And then you get that general solution. And we did this in the last video. You get the general solution of the homogeneous. Maybe we'll call this the homogeneous solution. Y homogeneous. We got was c1 e to the 4x plus c2 e to the minus x. And that's all in good. But in order to get the general solution of this non-homogeneous equation, I have to take the solution of the homogeneous equation, if this were equal to 0, and then add that to a particular solution that satisfies this equation. That satisfies that when you take the second derivative, minus 3 times the first, minus 4 times the function, I actually get 2 sine of x. And here, once again, we'll use undetermined coefficients. And undetermined coefficients, you just think to yourself, what function, when I take its second and first derivatives and add and subtract multiples of them to each other, will I get sine of x? Well, two functions end up with sine of x when you take first and second derivatives, and that's sine and cosine of x. So it's a good guess, and that's really what you're doing in the method of undetermined coefficients. You take a guess of a particular solution, and then you solve for the undetermined coefficients. So let's say that our guess is y is equal to, I don't know, some coefficient times sine of x. And if this was sine of 2x, I'd put a times sine of 2x here. Just because I want its derivatives to, I still want, no matter what happens here, I want the sine of 2x's or maybe cosine of 2x's to still exist. If this was a sine of 2x, there's nothing I could do to a sine of x, or nothing at least trivial that I could do to a sine of x that would end up with a sine of 2x. So whatever is here, I want here. Plus cosine of 2x, plus b, some coefficient, undetermined coefficient, times cosine of x. And once again, if this was sine of 2x, I'd want a cosine of 2x here. So let's figure out its first and second derivatives. So the first derivative of this, y prime, is equal to a cosine of x. Cosine derivative is minus sine, so minus b sine of x. And then the second derivative, I'll write down here. The second derivative is equal to what? Derivative of cosine is minus sine, so minus a sine of x minus b cosine of x. Minus b cosine of x. I think you're starting to see the hardest thing in most differential equations problems is not making careless mistakes. It's a lot of algebra and a lot of fairly basic calculus, and the real trick is to not make careless mistakes. Every time I say that, I tend to make one. So I'm going to focus extra right now. So anyway, let's take these and substitute them back into this non-homogeneous equation. Let's see if I can solve for a and b. So the second derivative is that. I'm going to add, from that, so let me just rewrite it, just so that you see what I'm doing. So I'm going to take the second derivative, y prime prime, so that's minus a sine of x minus b cosine of x. I'm going to add minus 3 times the first derivative to that, and I'm going to write the sines under the sines and the cosines under the cosines. So minus 3 times this. So the sine, let's see, it's plus 3b sine of x. So 3b sine of x minus 3 times this. So minus 3a minus 3a cosine of x. And then minus 4 times our original function. So minus 4a sine of x right? Minus 4 times that, minus 4 times this. Minus 4b cosine of x. And when I take the sum of all of those, that's essentially the left-hand side of this equation. When I take the sum of all of that, that is equal to 2 sine of x. I could have written them out in a line, but it would have just been more confusing. And now this makes it easy to add up the sine of x's and the cosine of x's. So if I add up all the coefficients on the sine of x, I get minus a plus 3b minus 4a. So that looks like minus 5a plus 3b sine of x plus, and now what are the coefficients here? What are all the coefficients here? I have minus b, and then I have another minus 4b, so minus 5b, and then minus 3a. So minus 3a minus 5b, ran out of space, cosine of x. This is the cosine of x should go right here. So anyway, how do I solve for a and b? Well, I have the minus 5a plus 3b is equal to whatever coefficients in front of sine of x here. So minus 5a plus 3b must be equal to 2. And then minus 3a minus 5b is a coefficient on cosine of x, although I kind of squeezed in the cosine of x here, right? So this must be equal to whatever the coefficient on cosine of x is on the right-hand side. Well, the coefficient of cosine of x on the right-hand side is 0. So that sets up a system of two unknowns with two equations, a linear system. So we get minus 5a plus 3b is equal to 2. And we get minus 3a minus 5b is equal to 0. Equal to 0. And let's see if I can simplify this a little bit. Let's see, this is a system of two unknowns, two equations. If I multiply the top equation by 5/3, right? Actually, no, let me multiply the top equation by 5/3. I get minus 25 over 3a plus 5b is equal to 5/3 times this. 5/3 times 2 is 10/3. 10/3. And the bottom equation is I have minus 3a minus 5b is equal to 0. Let's add the two equations. I get 10/3 is equal to, these cancel out. And let's see, that's minus 25 over 3 minus 9 over 3. Right? Minus 9 over 3a is equal to 10/3. It's getting a little bit messier than I like, but we'll soldier on. So let's see. Minus 25 minus 9. What's minus 25 minus 9? So that is 34. So we get 34 over 3a is equal to 10 over 3, or let's see, we can get rid of it. We can multiply both sides by 3, divide both sides by 34. A is equal to 10 over 34, which is equal to 5 over 17. Nice, ugly number. 5 over 17. And now we can solve for b. So let's see, minus 3 times a. This color is nauseating me. Minus 3 times a. 5 over 17. Minus 5b is equal to 0. So that's what? Minus 15 over 17 is equal to plus 5b. I just took this, put it on the right-hand side. And then divide both sides by 5. Actually, let me make sure. Oh, you know what? I realized I made a gross mistake here. Minus 25 minus 9. That's minus 34 over 3. So minus 34a is equal to 10. A is equal to minus 10 over 34, or minus 5 over 17. So minus 3 times minus 5 over 17. So that's equal to plus 15 over 17 is equal to plus 5b, right? And then we get b is equal to 3 over 17. That was hairy. And notice, the hard part was not losing your negative signs. But anyway, we now have our particular solution to this. Right? Our particular solution is, let me try to write in a non-nauseating color, although I think I picked a nauseating one. The particular solution is a minus 5 over 17 sine of x, right? That was a coefficient on sine of x, plus b plus 3 over 17 times cosine of x. And if we look at our original problem, the general solution now to this non-homogeneous equation would be this, which is the general solution to the homogeneous equation, which we've done many videos on, plus now our particular solution that we solved using the method of undetermined coefficients. So if you just take that and add it to that, you're done. And I am out of time. See you in the next video.